If you've ever come across Interstellar, the sci-fi movie released in 2014, you'd agree with us that it presents an intriguing scenario of life outside Earth. From multiple dream layers to time reversal, Interstellar pushes the concept of space travel to the extreme. But how do we even conceive the possibility of having planets orbiting a massive black hole and serving as potential human homes? Or a planet where time passes at a slowed down rate when compared to our own solar system? An hour spent on the Miller's planet is equivalent to 7 years outside the planet, that is, on Earth. But the main question remains, can the planets from Interstellar really exist? There is no doubt that Christopher Nolan, together with his team, was able to create a science fiction movie with a very intricate plot and beautiful scientific visualization. And in no small part thanks to physicist Kip Thorne from the California Institute of Technology. Apart from being just a sci-fi movie, Interstellar presents certain elements that are likely to occur. For instance, Earth in the movie is presented as devoid of food, water, or order. This is a possibility, especially when we consider the increasing pace of carbon emissions that threaten human life on Earth. Let's observe some concepts in the movie that are accurate from a scientific perspective. The first is the wormhole. Much of the action in the movie revolves around a gorgeous wormhole. The iconic film features Matthew McConaughey and Anne Hathaway, two astronauts traveling beyond the solar system and through a wormhole to find a habitable place for humanity before Earth becomes uninhabitable and humans are extinct from its surface. A wormhole is a theoretically possible structure that is based on Einstein's general theory of relativity. It is a tunnel that allows for relatively quick travel by bending space-time between widely separated parts of the universe. The wormhole presented in the movie is scientifically accurate. It had appeared near Saturn some years before. Theoretically, it is spherical in shape and portrays a distorted view of the target galaxy. But could this wormhole be the same black hole that was discovered in 2022 by an international group of astronomers? Well, the simulations provided by physicist Kip Thorne shows that they might be the same. He had co-authored a textbook in 1973 where the term black holes became popularized. NASA defines black holes as places in space where gravity pulls so much that even light cannot get out. The only difference between the movie's wormholes and real wormholes is that they cannot be seen with the naked eye. The hole is known as Gargantua in the movie. NASA in the movie had previously sent a team of astronauts known as the Endurance Team through the wormhole to 12 potential worlds as part of Project Lazarus, out of which 3 of them, Miller, Mann, and Edmonds, sent positive signals. The most habitable of them will host 5,000 human embryos to restart the human race. However, the black hole orbited by Miller's planet posed a lot of problems for the landing team. It powered tidal forces in its 2-foot ocean, creating waves hundreds of feet tall and also causing time dilation. Astronomers often think of a habitable zone in a planetary system as a zone where temperatures can allow for liquid water and where light can emit from the system's stars. In one of the movie's key sequences, upon realizing their failure at Miller's planet, the team decides to explore Mann's planet, which turns out to be destructive. There they lost a member and the only survivors, Cooper and Brand, attempt to reach Edmund's planet. However, they lack enough fuel and their only hope is to use Gargantua's gravitational forces to drive themselves there only if McConaughey, Cooper, ejects himself. We could see McConaughey Cooper detach himself from the Endurance spacecraft to reduce his weight and allow Hathaway Brand to reach the Edmonds planet. Cooper gets pulled into the black hole. But can someone actually survive in a black hole? Obviously, no. The reason is simple. According to research, the gravitational field of the black hole is extremely intense and changes very quickly. It is believed that anything that falls into it is stretched out into spaghetti by gravity. This nullifies the probability of anything surviving in a black hole. No one even knows what lies inside the hole. Nolan decides to exert some form of artistic license in depicting Cooper's journey into the black hole. And just like the science of what a black hole actually looks like, the Miller's planet also has an accretion disk, a hot disk that draws in matter from its surrounding. An accretion disk spins so fast that they can generate electromagnetic radiation before disappearing forever. However, rather than just ceasing to exist, the electromagnetic radiation, usually in the form of X-rays, goes into the black hole, thus increasing the mass. The chain continues and humanity is sent on the run again. If astronauts can actually end up getting as close to the disk around a supermassive black hole as we have it in the movie, they would actually be melted. However, despite the fact that it's not possible to survive in a black hole, it is possible to orbit it. However, this is as long as one doesn't get too close. In the movie, we could see Hathaway orbit the black hole, swinging round to reach one of the planets in the exoplanetary system. On the other hand, Cooper flies over it as if he's flying over Saturn's rings. In reality, he would be reduced to nothing. However, we can pardon the producers, as the accretion disk represented in the movie is not the same as the one in reality. It is static and frozen for reasons that are obvious to the director, of course. Another concept is that of time dilation. Is it possible to experience different times as depicted in the movie? Let's find out. According to Einstein, there is actually one entity, which is space-time. His postulation is based on the perception of space and time as different entities. His theory of relativity depicts space-time as a flexible material that can be warped by the objects in it, in this case, a planet. The result is gravity. The larger the object, the more space-time is warped and the greater the gravity. So the closer we are to the speed of light, the less time matches with someone who is not. In other words, a person in a place with less gravitational fields or potential will have time move slower relative to a person in a situation with mass gravity. This is exactly what the team experienced in the movie. McConaughey and his team explore the Miller's Water planet, which is very close to the gravity of the gargantuan black hole. This makes every hour on the surface equal to 7 years on Earth. Similarly, Romilly is orbiting Gargantua from a distance, making the gravity have less impact on him. It is important to note that time only slows relative between the two sets of people. When Cooper and his team get to Miller's planet in a shuttle, they discover the wreckage of Miller's ship in a large ocean. They are confused that the wreckage is still held together. Miller landed on the planet years ago. They then decide to stay a few minutes to obtain Miller's data. However, they are interrupted by a tidal wave that floods their engine and nearly destroys them. The team gets stranded on the planet for a few hours, only to realize that 23 years have passed on Earth. Cooper watches the messages he receives from his family. These messages have been building up since he left them. He then realizes that his daughter is now older than him and works for NASA. In essence, he has traveled in time. This is what the concept of relativity implies. If we assume that the spaceship in which Romilly is has a gravitational potential with that of Earth, people on Earth would also have experienced 23 years as well. This is based on the reality that no one experiences anything in slow motion. Also, if Cooper had put a GoPro on his head for the whole 3.5 hours and found a way of sending a live video to Earth, which is actually impossible because of the inability of information to travel faster than the speed of light, his daughter would equally see a 3.5-hour video and not a video in slow motion. The essence of this comparison is this: while it is true that time slows down near a black hole, it poses a big problem. Here is why. Getting such time dilation, a factor of about 60,000, requires one to be just over the surface of the black hole, and Miller's planet also has to be traveling at over 99.99% light speed. However, if we are to consider the way black holes twist up space, the minimum stable orbit around it, that is, the black hole, must be a minimum of 3 times the size of the black hole itself. At that distance, clocks would run a bit slower. In short, for the planet to have the huge time dilation as depicted in the movie, it needs to be too close to the hole to have a stable orbit. At the same time, being too close to the hole will have adverse effects and may cause the objects to stop existing. The reason is, as you've rightly guessed, due to the gravitational forces involved. It might not be a case of time travel, but a mere experience of time in a slow manner. Also, how does the gravity equation affect humanity? In the movie, Murph is on an undying mission to save humanity. This is known as the gravity equation in the movie. Though there is also a gravity equation in real life, the one depicted in the movie is quite different. Professor Brand and Murph are trying to figure out how to solve the problem of gravity in moving humans off the planet with the aid of gravitational propulsion rockets. This is in line with Einstein field equations, where he conceptualized the possibility of creating gravity of your own. With success, it would be possible for an individual to lift entire cities into space. Ultimately, Einstein's work, with a little help from Mirth and some form of transdimensional interaction, saved humanity in the movie. While the equation exists in some form, it is not sufficient enough to help humans evacuate Earth anytime soon, and the simplicity with which the Endurance spacecraft landed doesn't seem plausible. If NASA had such propulsion, they would have gone a lot of places a lot faster. But then there was a causal loop which could be regarded as a philosophical puzzle. The major reason why Cooper went on the mission was to send Murph signals explaining how to get to the NASA installation. NASA had been hatching a secret plan to save humanity. The twist, however, is that he was able to send Murph these signals because he went on the mission. Don't get confused. In simple terms, the causal loop in the movie, as presented by Professor David K. Johnson of King's College, is that a future version of Cooper in a black hole creates the dust patterns that lead the past Cooper to act in a way that prompts his travel to the black hole. And beyond the planets presented in the Interstellar movie, there are lots of other planets as revealed by NASA. In one of its blogs, NASA opined that it's yet to find a planet that is exactly like Earth. However, its Kepler Space Telescope has discovered a lot of potential Earths. The implication of this is that future generations will have many worlds to explore. Now, remember the scene where Dr. Brand said, "There is no saving Earth, we have to leave it." Do you believe that humans might have to relocate from Earth to a different habitable planet someday? Or are scientists just making up stories and making Earth seem so sick enough as to garner enough support to help fund their adventurous space trips? Do you even believe there are other Earth-like planets out there? Let us know what's running through your mind in the comments.